poster with an endothermic or exothermic process. So let's go back, and who can tell me what an endothermic process is? What? He's going into the system. Good. What is an exothermic reaction? Heat is leaving the system. So we just heard the word system. So what, not looking at this example, but what is the definition of a system? Good. The thing you are watching or observing. And then what are the surroundings? Everything else. So for this example, we've already talked about boiling water. We know that water is what we're observing, right? So that's the system. And then everything else would be like the stove, the pot. If you have a gas stove, it would be the fire that it produces. The air, the kitchen, the person who's boiling the water. So that's all the surroundings, okay? So it's everything other than the system, okay? And then we know that it's an endothermic process. You told me that heat is going into the system. So with this poster that we're going to be doing in groups, so there's groups of 3 or 4, I have a flashcard. I'm going to pass them out to each group. And then as a group, you will figure out if it's endothermic or exothermic, and then explain to me why it's one of those processes. So some of them have different, you can define different systems. Okay, so some of them, like for example here, I could define the pot as my system. So it would still be endothermic because the stove would be it would be giving off heat. The stove would be giving off heat, so the pot would be absorbing it. So that could be another system. If I said that the flame from the fire is the system, is that endothermic or exothermic? Exothermic, because it's giving off heat, right? Heat is being released from the fire. It's going into the pot. Yes, so does that make sense? So some of them, you can define different things as the systems. So you can also use that in your explanation. So just a basic overview, you're going to put the phenomena that I give you, so the note card that I give you, that I'll pass out as a group, or to your group, then you'll draw a picture of what's happening. Okay, so you will tell me, so here's my pot of boiling water. My heat is going into my water, into my system. Okay, so you want to draw arrows to show that you are going, or how you are, or what you're representing. Okay, so here you can clearly see that my water is my system. The heat is going from the outside in. Yes, we all see that? Awesome. So I defined my system. So my system is the water. And then I defined my surroundings. So my surroundings are the stove, the pot, the air, the kitchen, the person. And then I will come up with an explanation. So my explanation, which we already know because we've already done this, boiling a pot of water is an endothermic process. The heat from the surroundings, so everything around it, is being absorbed by the water. So the water is absorbing that heat, taking it in. Okay, in other words, heat is going into the system. So for your explanations, I want you guys to come up with at least 5 sentences, so it's a paragraph. Okay, so at least 5 sentences. So this is a very brief explanation. You can use similar words, but I want you to use endothermic and exothermic. I want you to use words like absorb, release, heat into or heat out of the system. Talk about the surroundings. So come up with at least 5 sentences. And then tomorrow, we'll work on it today, we'll work on it a little bit tomorrow, and then tomorrow we're going to present to the class. So all of these things that are on the note cards are examples of, or things that you see on a regular basis. So some of them would be like lighting a match. One would be burning candle. There's a baking one. There's cooking. There is photosynthesis. Okay, so there's different examples. We see this on a regular basis. We might not realize that we're doing chemistry, but it is because we're transferring heat, that heat flow. Okay, so we're going to use our knowledge from what we've already learned to come up with a consensus on whether your process is endothermic or exothermic. Okay, do I have any questions from you guys? No? So this is going to be what your poster looks like. So you're going to show a poster or do a poster on a piece of construction paper. So you can do it this way, you can do it this way, I don't care. But make sure your phenomena is on there. So mine would be boiling a pot of water. Then you'll draw a picture, and then you'll define the system, define the surroundings, and then define or give me an explanation of what is happening. Okay, I'm gonna walk around to each group. So some, yes, I already told you that some you could define, depending on what you define as the system, then it would change whether it's endothermic or exothermic. So in your explanation, you can talk about that. If I defined this as the system, then it would be the opposite type of reaction. Okay? The reason that I want you guys to really, really understand endothermic versus exothermic is when we move on next week, we're going to start talking about chemical reactions. So it's important to know where heat is going, where energy is going, if it's going into the system or if it's leaving the system. Okay? Are there any questions? No? Okay, I'm going to put your groups up. Go ahead and you can get into your groups. I have construction paper up here, colored pencils, white paper if you want to glue a piece of paper onto your construction paper, scissors, glue, markers, rulers. If you need anything else, you can ask me. Yes? Yes, I'm gonna put your groups up here. So I want you guys to work in new groups. You guys always seem to work with the same people, so I want you guys to start meeting other people. Yes? Yes. All right. All right, so here are the groups. So group 1 will be Carlo, Ricardo, Julie, and Jose. Group 2, Michelle, Azucena, Adrian, Marlene. Group 3, Catherine, Elise, Jasmine, Felipe. Group 4, Nanetzi, Adam, Priscilla, Charlize. Group 5, Daisy, John, Kayla, Berenice. Group 6, Diane, Michael, Melanie, Shayla. Group 7, Dannery, Jennifer, and Daniel. Group 8, Keith, Narcisco, and Luis. And then group 9, Roger, Jesus, and Christopher. So go ahead and get into your groups, and then I will come around and pass out the situation. Okay? If you don't know somebody, you can ask me or ask a friend. Introduce yourself to your new groups. Michelle, raise your hand. Okay, let's see, Daisy, raise your hand. Her niece, that's you. And then Sheila, Jasmine, Felipe. Where's your group? Okay, so Jasmine right here. Keith and Narcisco. Where are you guys? Keith, Narcisco. Oh, they're back. Okay. Anybody else need to find their group? So guys, working in a line probably isn't going to be very good. So you guys want to like face each other, maybe put chairs on the opposite side of the lap bench, turn chairs around. Okay, I'm going to walk around and give each group a topic, okay? All right, so you four are a group. You. So you guys have burning a candle, right? So describe to me what happens when it's the wax starts to melt and then yes.
Sugar?
Put on 7.
I'm not sure.
Okay, the fire's burning. Good. So there would be 2 different systems. So what are you guys defining as your system? You're defining the fire. Okay? So what's happening to that fire? It's releasing heat. Awesome. So is that an endothermic or an exothermic? Exothermic. Good. So where's that heat going? Into the candle wax and And the surroundings. Awesome. So if to switch it up, if I were to define the candle wax as endothermic or exothermic, what would that be? Endothermic. Why? Tannery, why? So is the candle absorbing or releasing chemical gases? Good, it's absorbing. So those are two different ways that you could define the system. Okay, so you can say that in your explanation. When you're talking about your explanation, you can show. Okay, good job. All right, guys, how are we doing over here? Good? Okay, so you guys have the production of sugar photosynthesis. So can you explain to me what photosynthesis is? One of you. So you have to go back to your biology class.
When sunlight is shining on a plant, it creates either oxygen and
Awesome.
sugars.
Okay, so the sun is beating down on the plant. Which way is the heat going? So you're telling me the plant is the system or the surroundings?
The surrounding.
It's the system. Okay, so is the sun part of the surroundings or the system?
Surroundings.
Surroundings. Good. So when that heat is going into the plant, so that makes it endothermic or exothermic?
Endothermic.
Endothermic. Awesome. So then, did you guys look up chemical potential energy?
No.
Okay, so when we're talking about bonds, when we form bonds, we have your energy stored within those bonds. Okay, and then when we break bonds, we release energy. Have you guys ever played Red Rover? The game Red Rover? No? Okay, so it's basically a game where you hold hands and someone tries to break through your hands. You know, you've never played like Red Rover, send whoever on over. Okay, it's like an old school game. I used to play it in elementary school. Anyways, so when you hold someone's hand and you form a barrier. Do you think if I'm standing here by myself and one of you were to run, do you think my arm's gonna just shoot back? Yeah. Yeah. So I'm releasing my energy, right? What happens if I held hands with Shayla and Diane, you ran through? Do you think you'd be able to run through? No, because we're bonded, so we have more energy. Okay, so does that make sense? So when I have a bond, I have more energy. When I don't have a bond, my energy is being released. So that should help you with producing sugar. So you're forming, producing means you're forming those bonds. Does that make sense? Yes? Alright, how are we doing over here? You like your drawing? So, you guys have using an ice pack. So what did you define as the system? Because it looks like I have a couple different systems here. So you're saying the ice pack is the system, okay? What are some surroundings? Okay, what else? What are some other examples of the surroundings? The air? Okay, good. The sun if you're outside. Awesome. So, is my ice pack taking in heat or releasing heat? It's taking in heat. So, if I have it on my foot, so say, now I want you to, sorry. So with my ice, is it endothermic or exothermic? So it's taking heat in, right? Okay. What about my foot? What if I describe my foot as the exothermic? Good. Okay, so Jasmine and Catherine, do you understand why? It depends on what, so if I have my ice, and so Felipe and Lise told me that it was endothermic. So what does that mean, endothermic?
I know, they look kind of
Where's heat going in an endothermic reaction? It's going into it, right? So where's the heat coming from? That's where it goes in. It's coming from the foot. Awesome. So it depends on this one, it depends on what you're defining as a system. So you have both an exothermic and an endothermic reaction. But since you're defining your ice pack as the system, you did figure out that it's endothermic. Awesome. Yes? You have a question? Yeah? Okay, what's up? have cellular breakdown or cellular respiration. So you're breaking bonds. So you could draw a sugar, like a sugar molecule. Just Google what sugar molecule is, and then you could show it forming and then breaking. Okay, so do you guys know what molecules are? Molecules are chemicals. I know we haven't talked about that yet, but when you form bonds, it's that energy stored in those bonds, right? When you break bonds, it is being, what's happening to the energy? It's being released. So is your breakdown of sugars endothermic or exothermic? Exothermic. Awesome. Okay, so your picture, if you Google cellular respiration, you can do that. There's a system, if you look up photosynthesis, it's opposite of photosynthesis because photosynthesis is creating the bond. So it's opposite of that, so you could draw something like that, or just something breaking, okay, and releasing energy. So you could show like a molecule being bonded, and then you could show that energy being released. Okay, does that make sense? Yep, awesome. All right, how's my group over here? Where'd your other group member? Over there getting materials? Okay, so you guys have lighting a match. So did we decide if it was endothermic or exothermic? Exothermic. Okay, so Luis, what did you define as your system? The match, so the wood part? Or are you talking about the flame? The wood part, okay. So you said it was exothermic. So the wood, think about it this way, is the wood releasing heat? The flame is releasing heat. So if you said that the match is the system, do you have it backwards? Is it endothermic or exothermic? It's endothermic because the match is taking that heat in, right? So it would be an exothermic process if I defined what as my system. The fire. Good. So think of it as, think of a campfire. So think of it as upon a big scale. When you're sitting by a campfire, you're getting warmer, you're getting cold. You're getting warmer because that heat's coming off, right? What's happening to the wood? It's burning. So is it taking the heat in or is it releasing it? Good, it's taking it in, so that would be endothermic. So think about it that way in terms of a match being a small scale campfire. Okay, so you might want to redefine your system or think of it as a different process. Okay, awesome. Do you have any questions? No? Okay. All right, how are we doing over here? Good, you just figure out, so you guys said that your system is the snow. So what's happening when we form snow? What's happening to the water clouds? What? What's happening to the water when we form snow? It's freezing, so it's just like making ice cubes, right? So is it an endothermic or an exothermic reaction? Exothermic. So what is releasing the heat? The snow, but it's in the clouds. So yes, the clouds. So what I would have you guys do is show me using arrows where the heat is going. Is it going into the snow or is it going out of the snow? Good, it's going out of the snow. So it looks like you guys understand that freezing things is an exothermic process. So now I just want you to show me using your arrows how to do that. Okay? All right. One more. All right, how are we doing over here? Using a hot pack. That doesn't look like science. Okay, do you guys know what a hot pack is? Yeah, what's a hot pack?
To warm up.
Good, to warm up. Good. So, do you know who would use it? Who has a reason to use a hot pack? When you're cold, good. What about athletes? When they hurt themselves, good. So, let's see, it says you guys, the hot pack is an exothermic process because it's releasing energy. Good. So what did you define as your system? Hot pack. What is your surrounding? What are your surroundings? The body or the human, what else? Okay, so I think that's the body. What are some other surrounding things? Good, where they are. What about, what am I in right now? A room, or if you're outside. So good. So what I want you guys to do though is show me, you drawing arrows, show me where the heat is going. So I see your hot pack, your explanation, it needs to be at least 5 sentences, but draw where your heat is going, okay? Tell me maybe, what's another way? What if I defined my system as the body? Would it be endothermic or exothermic? So if I put a hot pack on my knee because I hurt it, and I'm defining myself as the system. So where's the heat going? It's going into me, right? It's leaving the hot pack and it's going into my body. So that shows you your law of conservation of energy, because it's not being created and it's not being destroyed. It's going from something to something else. Okay? Awesome.